Okay, so this is Rational Zero Test. This is one of the more clerically challenging tasks for this course, although it is not that exciting, I guess I would say, but it does take a little bit of clerical follow-through. Step one is you have to find factors of the leading and trailing coefficients. And might I add that every one of these coefficients has to be an integer, or else this theorem doesn't work. Okay? And what it's saying is if all of our coefficients are integers, then we should be able to look for rational zeros using this mechanism. Clearly I can say x squared plus 3 equals 0, right? And that doesn't mean I have any roots. Or I could say x squared minus 3 equals 0, and then the roots are plus and minus square root of 3. So it doesn't mean I have to have any rational roots. But if I do have rational roots, I should be able to find them by this mechanism. Okay, so I'm going to break up 2, and I'm going to break up 30, and ignore for the fact that, ignore that there's plus and minus, because that's just a nuisance and we can deal with that later. Okay, so we only have 1 and 2 as factors of 2. The factors of 30, oh my gosh, 1, 2, 3, 5, 6, 10, 15, and 30. Okay, so step 2 is ratio list. All right, you got to make all your ratios factors. I'm just going to write it this way: factors of 30 over factors of 2, where the 30 is the guy on the end and the 2 is the guy in the beginning. So let's go for it. So factors of 30, let's just look at this for a second. There's all my factors of 30, and they're all over 1. And I'm going to write them again and put them over 2. But wait a minute, 1 over 2 I need, but 2 over 2 I don't need because it's already there. 3 over 2, 5 over 2, 6 over 2 I don't need, it's already in the list. 10 over 2 is in the list. 15 over 2 I need, but 30 over 2 I don't need because it's already in the list. So we only add 4 more to the list. And of course this means we include all the pluses and all the minuses. How obnoxious is that? It is. It's very obnoxious. So we try for the easy ones first. Low-lying fruit first, right? Because this thing is only x to the 4th. So if we can tick off 2 really easy ones, then it will just be a quadratic, and then we can just use the quadratic formula. So let me show you what happens when you guess incorrectly, right? So f of 1, if we just pull out your calculator and say 2 minus 9 minus 18 plus 71 minus 30. And then you find out that f of 1 is 1. And so you put a little frowny face. That didn't work. Okay, let's try f of negative 1. And so it's going to be 2. But see, this is, put a negative 1 in there, so a negative 1 will come out. Negative 1 squared is still just 1, so you'll have a minus 18. Negative 1 is going to flip this guy's sign, and minus 30, and I'm not even going to bother calculating it because this stuff is over 100 negative, over negative 100, and that measly little 11 is not going to do anything for us. So we cannot, this guy has been eliminated as an option. And I think, okay, I really don't want to deal with any of the fractions, so the next thing I have to try is f of 2. Right, so I try f of 2. And it's going to be 2 times, let's see, 2 to the 4th, 2, 4, 8, 16, okay. Minus 9 times 8, minus 18 times 4, plus 71 times 2, minus 30, and I'm not going to get my calculator out. I'm just going to let you get your calculator out. And you're very, very happy because we got ourselves a root. And then what we do is we go ahead and say, well, since we know it's got to work, then if x is equal to 2 is the root, the factor looks like x minus 2. And I'm going to go ahead and put this big mess inside that division symbol. I'm copying it off a piece of paper, but it's just the same thing that's above. Okay, alright. Now, I'm going to ask the question, how many times does 2x to the 4th go into x? That's my question. And it's going to be 2x cubed. That's how many times. So I'm going to multiply 2x cubed times x, get 2x to the 4th. Then 2x cubed times negative 2 is minus 4x cubed. And I'm going to go ahead and change the sign. I'm going to say, because I'm going to subtract. I like to change the sign. You may prefer to leave the signs alone and subtract, whatever works for you. Negative 9 plus 4 gives you positive 5. And then you have to drop down at least one more piece here so that you can continue this process. Okay, so let's see, what's next? Well, I have to ask, how many times does 5x cubed go into x? And the answer is going to be plus 5x squared. Except I made an error. See, this is, I just checked my answer key. This is supposed to be a minus. You guys didn't stop me. Of course you didn't. This is a recording. Okay, so now let's go ahead and multiply minus 5x squared times x, and we get minus 5x cubed. Then minus 5x squared times minus 2, we're going to get a positive 10x squared. Again, I'm going to just change the signs and add, and I'm going to get minus 28x squared plus 71x. And someone's going to say, hey, what if I do that on an exam? I mess up that sign. Well, I'll tell you, I will have a lot of sympathy for you, provided you show all your work. And more than likely on an exam, I will give you just an x cubed problem, not an x to the 4th. But it's a practice exam, so I can do this. Okay, so how many times does negative 28x squared go into x? Okay, so we want minus 28x. So we get minus 28x squared down here. And then positive 56x goes here. And again, we're going to change the signs so we can add. As 71 minus 56 is 15. Then bring down the 30. And if you've done everything correctly, then this should be the last round. And then you should have 15x minus 30. Now, let's say you got this far and it didn't work. Then you write me a little note over here that says, I expected to get a 0 here, so I must have made a clerical error upstream, and I don't have time to mess with it. It's an exam. Then you just make up numbers and say, I pretend like it worked out. And you say, like, I understand that it didn't work out, but it was supposed to. And then I will be very merciful because I see that you know what you're doing, you know how to check your work, you're running out of time, but then you go to the next stage and you know what's supposed to happen. Okay, so that's totally fine with me. Alright, so let's say we continue. So now what we have is we have this up above becomes our new problem. And so we get to do the whole thing all over again. So we have 2x cubed minus 5x squared minus 28x plus 15. But if we look at our original list, we've now dealt with the plus 2. We might want to try negative 2, but let's just do the whole list from scratch again for practice, because the new list will probably have missing things in it. I mean, our new list may be smaller than our old list of possible factors. So we're going to factor 2 is 1 and 2, and 15 is only 1, 3, 5, and 15. So factors of 15 over factors of 2 are now going to look like this. But we already know we took care of the ones, so these guys are off our list. We definitely don't want to mess with fractions if we can avoid it. It kind of defeats the purpose of having a clean problem here. And we were about ready to try 2 as our next, negative 2 as our next try, but uh-oh, this list tells us we don't need to try negative 2 because it's not possible for this new polynomial. So aren't we glad we went ahead and did this work a second time so we didn't waste our effort trying the negative 2. So the only thing left to try, we try the 3, we hope it works. If not, we try the negative 3. And if that doesn't work, we're going to get very frustrated. Okay, so let's call this F2 or G or something like that. F2 of 3, 2 times 3 cubed minus 5 times 3 squared minus 28 times 3 plus 15. And you put that into your calculator and you get negative 60, so you're very unhappy. And then you just try again with a negative 3. It's going to be pretty much the same, but we're going to switch signs. So these guys, because when I put the negative 3 in here, for example, that negative sign is going to stick around and annoy us. But with x squared, it's not going to make any difference. So, and yippee, it ends up working. Put it in your calculator, you find out that it works. We are very, very happy, but then we have to do synthetic division again. Thankfully, it's not that onerous this time. It's a much easier problem. So we go ahead and do that. X plus 3, don't forget it's plus 3, not minus 3. Alright. Alright, now let's go ahead and work this out. 2x squared gives us 2x cubed plus 6x squared. Subtract. And let's see, we get minus 11x squared minus 28x. So I'm going to say minus 11x over here. Alright, so change the signs and add. And it's going to be 5x plus 15. So we're going to say plus 5. This is 5x plus 15. You don't have to finish at this point. You just have to be happy that it worked. Okay. So finally, you want to factor 2x squared minus 11x plus 5, and that gives you x is equal to negative b plus or minus the square root of b squared minus 4ac, getting ahead of myself, all over 2a. Okay, so that's 121 minus 40, right? 121 minus 40 is equal to what? It's actually 81. So that whole mess is just the square root of 81, so it's 9. So x is 11 plus or minus 9 over 4. So that splits into two cases. If you put the plus in there, you get 20 over, no, you get, yeah, 20 over 4, which is like 10 over 2, which is 5. But if you use the minus, 11 minus 9 is 2 over 4, which is 1/2. Okay, so all the factors together, f of x has factors 1/2, 5, minus 3, and 2 in no particular order. Yes, that is a long problem, but aren't you glad that I did it and not you? Just kidding. Now you should turn off the video and do it all yourself from scratch. Make sure you got all those steps. It's a really good practice.